Abhishek Sharma from class 9th KVPK. Today, my task is to speak on the electrodynamics of a moving body by Albert Einstein.
Let's have a short introduction on Albert Einstein and his theory. Albert Einstein was a German-born theoretical physicist, widely acknowledged to be the greatest in his field of all time. This edition of Einstein's on the electrodynamics of moving bodies is based on the English translations of his original 26 September 1905 German language paper.
I am trying to explain it to you with the help of my presentation. So let's start. This also comes under the theory of relativity by Albert Einstein. How many sticks do you see here? Blue says 4 and green says 3. Actually, both of them are correct as they are in different reference frames. Now, what exactly are reference frames? They are a point of view that one has to determine an object, the action of any object. Let's take this example. Suppose you have a car and there are 3 observers. One is you inside it, second observer in front of it, and the third behind it. Once the car starts honking, the 3 observers will receive 3 different signals. We must remind ourselves that sound is a wave. It is bunched up in the front and looser at the back. That was the back person. That was the middle person, which is you. That was the front person because of the difference in the frequencies. So what sound was the car actually making? Well, it was a very big sound, which I don't want to hear myself. But that was the actual sound of the car. Because there are 3 persons, they have 3 reference points. But if there were infinitely many reference points, there were infinitely many. That is the real sound of the car for all these people. So if there are infinitely many people, there are many sounds. They are all wrong. They don't have the correct sound themselves. The second theory is the speed of light is same for all the observers. This is called time dilation. Time dilation is a theory of special relativity. Now let's imagine a beam of light. It is being reflected between 2 mirrors, up and down. Now replicating this setup, we take another setup of 2 mirrors and a beam of light. But this time the mirror is moving close to the speed of light, which is immense. We can see in that this moving set of mirrors, the beam of light is actually moving at a greater distance. The speed of light must be the same for both the mirrors, but the light is covering more distance in the second part. How is that possible? Well, the only way for this to work is that time slows down for the second example. Let's take it this way. Distance is equals to speed of light constant. Speed of light constant multiplied by time, which is immense. Since the light being on the moving object is traveling larger distance in a small time, time is going slow for it. This only means that moving clock runs slow. If I run so fast, I run faster. The clock is still slower. Shelly Annie Fraser Price, the woman who broke Usain Bolt's record. Suppose she ran at 96.8% speed of light. That's only 10 seconds for her to complete a race. But for the stationary judge, it is 40 seconds. Naturally, Price will say that no, that's 10 seconds. She might have broken 1,000 records. That their argument is pointless. Time is relative. Observers in different frames will consider different realities which they see. not what is real, because they are in different reference frames. But what will happen if these objects you see here, they are slow, they are in slow motion, we say slow mo. But what if all these objects start to speed up? They are like zoom, and time around them causes curves. Einstein had said, what about the effect of gravity? What is the actual gravitational pull? So Einstein theorized that the objects, they wrap space around them. They cause curves in space, they cause warps, and other objects experience gravitational pull. The satellite experiences gravitational pull to Earth. That is the reason. It's quite confusing, right? We all must not have understood it at all. So to understand, just for the sake of understanding, let's think that this rectangle is space. Now I take Earth, it's not there in my hand, it will come now. I put it in here, it will appear. It has made a warp around it. And now, you see it goes down, space curves near the planet. This is what Einstein theorized. And if I take Mars or any other planet, I place it somewhere here. You see, it makes a curve around it. It makes a warp. So this explains how gravitational attraction comes. You see, the moon is attracted because of the curve of the Earth. The warping of space-time explains how objects behave while in space or as they move through space. This is the theory of electrodynamics of a moving object. But before finishing, let's theorize or summarize what we just did. We talked about reference frames and how it affects the viewer in the different reference frames. We talked about the theory of relativity, which is also in aerodynamics of a moving object. We spoke about general theory of relativity. We learned about time dilation and also all these many theories which I mentioned right now. So this was all about the electrodynamics of a moving object. So I am also a moving object as I am moving from here to here. This is all about the electrodynamics of a moving object. Hope you liked it. Thank you. Have a good day.